In the last video, we saw how to calculate the torque of a coil, a current carrying coil that is encased in a magnetic field. So we saw that the torque was equal to NIA B sine of theta, where N is the number of turns in the coil, I is the magnitude of the current, A is the cross-sectional area of the coil, not of the wire, but of the coil, and then B is the magnetic field. We can do better than this though. What we can say is that the torque is equal to mu cross B, right? The cross product is going to take care of the sine theta. And if I'm going to do this, I'm going to have to define mu. Mu is what we call the magnetic moment, which is defined here as NIA N hat, where N hat is the unit vector perpendicular to the area here. This is AN is the I should say perpendicular to the plane of the area. If this loop forms a plane of area A, N hat will be the vector perpendicular to that. This forms the A vector. This is called the magnetic moment of a loop. Of course, if N is equal to 1, that just goes away. Sometimes you'll see N written outside of this, but your book, and so I will use this convention, N is written in as part of mu. To basically characterize mu, the direction of mu is going to follow the right-hand rule. So if this is a current, and this is a loop with some radius r, that makes it easy to calculate the area. The magnetic moment will be a vector perpendicular to this loop. To tell if it goes up or down though, we use the right-hand rule for fields, which is to say I put my fingers in the direction of what's curved. In this case, the current is curved, so if I wrap my fingers around that loop and stick up my thumb, I'm going to get a vector up. And so the magnetic moment of this loop looks like this. Of course, if the current was going the other direction, it would be down. But the magnitude of this vector is equal to the current times the area. Of course, this is just 1. If I had these stacked up, I would get a total magnetic moment, which is N times this one loop of current. But this is the magnetic moment due to one loop of current, is just IA N hat.